So, for our vocabulary, I feel like central angle is probably the one we talked about the most. The central angle is when the vertex of that angle is at the center of the circle. So making sure that that's clear. Now, just to make sure we understand, the vertex of an angle is the point of the angle. Like it's the like the sharp part. Like if you were thinking about it as where the two lines come together. So if we're looking at like angle 2 here, it's going to be the same as this x value. So the measure of angle 2 is going to equal the value of x. So we don't have to do like 1/2, we don't have to, you don't have to add anything together, we're just like looking at that angle is the same as the arc. But also a reminder that these angles together should add up to what? Yep, so the 3 angles together should add up to 360 degrees. And so should like the 3 arcs as well. So those angles should add to 360. And so central angle we learned about first, and we used it throughout the chapter quite a bit. But we learned other rules, so I don't want you guys to forget about that basic rule there. All right, so the next part is talking about chords and arcs. And basically, if we have equal chords, then we have equal arcs. I wanted to change the color. Let me. So if these chords are the same, that means that then the arcs are also the same. And we use like a double arrow with this to show it works either way. So if I have those chords that are equal, then I have the arcs are going to be equal as well, and vice versa. It goes both directions. And so part of this is trying to identify what situation we're encountering in a question. What are we looking at? Are we looking at chords? Are we looking at arcs? Are we looking at the angles? Trying to determine that. Our next one is when we have a diameter and a chord together, and they're perpendicular. So the diameter is perpendicular to the chord. And remember that upside down T means perpendicular. If that's the case, then we know that these two are equal. And also the same thing with the chords. So XB is going to be equal to BY. In our notes, and maybe in our homework as well, sometimes it's helpful to draw in a radius. When we draw on that radius, and I'll show you guys with maybe a different color green here. If I draw in like XC, then I actually have a right triangle there. Then we can use Pythagorean theorem if we need to find parts of that shape. Then we talked about inscribed angles. And an inscribed angle is an angle that the vertex is now on the circle. This is one of the ones we dealt with last class as well. So this one showed up in a couple of sections. So that measure of that angle 1 is going to equal half of that arc from A to B. So I was just talking with Holton about that for his scrimmage, is that this angle is half of the arc. So vice versa, if you know the angle, you have to double it to find the arc. So if that helps to write it another way, so the arc is double the angle. It works both ways there. We talked about an inscribed quadrilateral, and an inscribed quadrilateral is a four-sided shape. So it's only for four sides. This doesn't work for like a pentagon or a hexagon or anything like that. Just a four-sided shape where all the vertices are on the circle. So, oops, if I can spell. So a four-sided shape where the vertices are all on the circle. What was the really important thing to remember with this? We know about, there's something special here. Okay, what's it with you out there? What's that? Oh, yeah. What do we know about, there's something special here, guys. What do we know? What do I know about the opposite angles? They're not equal. What's the other thing they could be? They add up to 180, yep. So they're supplementary. And again, if you don't remember that right now, you're not going to remember it in 2 weeks. So make sure you write it down. I'll write it in another way. Maybe I'll help you remember. And again, that's only for a quadrilateral. It doesn't work for any other shape other than the four-sided shape. Our next one is we have two inscribed angles in the same drawing. And so this is a kind of strange one. It's kind of hard to like visualize because there's a lot going on here. The two angles intersect the same arc. So like C and B are going to be equal because they both intersect arc AD. And they're also going to be half of arc AD, so that's probably important to point out. And the same thing goes on the other side here. So if I change this up, these two over here are also going to be equal. And they're going to be half of the arc they're across from, which is over here, this BC. My board's not listening to me right now. It's probably going to freeze, I was going to say. All right, be quick. We are going to go to the back. We're going to finish this last one. We are going to do some on the back side as well. I know it kind of seems annoying that we have to do so much today, but we'll get them down and then we don't have to worry about. The only thing we're not going to do is the very last line. So when I said we were doing chunk of this, we're really doing a lot parts of it. Oh, maybe I'm wrong about that. Oh no, yeah, we're only going to go halfway down the back side. Never mind. I always forget what we've learned so far. All right, so our inscribed triangle. Now, with our inscribed triangle, one of the special things about this can't just be any triangle inscribed. We have to have a diameter as a side. So just to make sure you understand, this doesn't work if I just draw, so like if I drew a triangle down here. So if I just did a triangle within my circle, this does not work. So this is not what we're talking about here. So an inscribed triangle, when I talk about that, what I mean is the diameter also has to be a side. So this diameter is the side of our triangle. What do I know about every triangle that has a diameter as a side that's inscribed? You guys remember this? We all drew unique ones, but they all had something in common. They have a right angle, so they're all going to be right triangles. And again, it's because of the fact that the diameter is that side, that this over here would equal 180, and that one over there is supposed to be half of that. So there's a lot of reasons why that is, so that like making sure that you don't have to just worry about memorizing that makes sense. It's always going to be a right triangle. But again, that's only if a diameter is a side. So the one I drew down here is a bad example of it because the diameter wasn't a side. All right. So we're going to flip the sheet over. We're going to go, we have 4 more to do. And then the rest of them we get to save till after break. And then we'll finish up these last 4. You guys are going to get a homework assignment that goes along with these first few sections. And like I said, I want to give you guys time to work on it so that maybe you don't have to take anything over break home with you and you can just kind of...
Oh yeah, today's Friday. We have spring break next week.
Spring break starting. A snowstorm's coming in honor of spring break. Yeah. We're supposed to get like a huge snowstorm like tonight.
Really?
Yeah. I hoping they're wrong, but okay. Okay, so we have two tangents that share a point. That means those tangents are going to be the same length. So if they share a point, they're going to be the same length. So tangent to the same circle that share this common point of B, you automatically know they'll be the same. All right, so these next few are talking about the vertex of angles. So these next three, if you want to write that like down the side, these are all, anytime they talk about a vertex, we're talking about angles here. So starting here, down to the third one there. So this is where we talk about inside, outside, and on the circle. So if the vertex is inside the circle, we have a formula for this. Again, this goes to angles to this point. That's where we'll stop today. So the measure of angle 1 here is given by half of the two arcs that are used to create it. So this AB and then DC when we add them together. So think vertex inside the circle. Inside we're going to add them. So think inside is plus. You can also figure out angle 2 if you wanted to there. So if you see that right, angle 2 also works the same way, but it's going to be the other two arcs. So half of BC plus AD. So just that you guys know you can find either one. We also see that there's vertical angles here, there's linear pairs, that means they add to 180, there's a lot going on there. Now the vertex inside the circle is technically an inscribed angle. So we actually had that on the front side already. This is the one that's going to be half of the arc it works with. So angle 1 is just going to be half of arc AB. Bless you. Or we could say angle 2 is half of the arc ACB. It goes either way with that. And then our last one is when the vertex is outside the circle. So we have on the circle, in the circle, now we're outside. Outside, inside was addition, outside is going to be subtraction. So that's a way to remember the difference, but again, you'll get some sort of cheat sheet to use for this. So I'm going to give some letters here. So we can call that A, B, C, D. We're going to call this angle 1 out here. So it's half of the two arcs. It's always the bigger arc first, or the one that's further away. That you're subtracting those two arcs. Okay. So what we're gonna do